Welcome to this video. My name is Mark Scythian. The date today is May 22nd, 2025. So this video is going to focus on battery internal resistance. So whenever we have two or more cells connected, this comprises a battery. So in this case, we'll work with a 21 cell lithium polymer battery for which the 21 cells are connected in series. So that is going from positive to negative and then negative to positive. So when working in series circuits, the current will remain constant. However, the voltage in this case is cumulative. So we could multiply the 21 cells times their 3.6 volt DC rating per cell, and then calculate a battery voltage of 75.6 volts DC. So assume we connect this lithium polymer battery to a DC electric motor, and then we turn on the motor. A point of interest is the battery's internal resistance, especially when it's under a load. So we place an ohms meter across the DC electric motor's circuit while it's running. We measure 2 ohms of resistance, so we call that the load resistance. And then the lithium polymer battery has a current capacity of 6,500 milliamp hours and a 5C discharge rating when the motor is energized. So we could simply divide the 6,500 milliamp hours into 1000 to get amp hours, and then multiply this times the 5C discharge. So we calculate 32.5 amps as the current discharged to the motor, and then we know that current remains constant across a series circuit, so there's exactly a 32.5 amp load and no load potential current when the motor's on and off based on the 5C discharge rating. So we place 32.5 amps DC. Then we access Ohm's law for DC circuits, and this is E voltage is equal to I current times R resistance. So if we were to make the calculation, we would then multiply the 32.5 amps times 2 ohms. And so this motor is discharging exactly 65 volts from the 75.6 volt battery. So the motor draws 65 volts DC from the battery. So we can take 75.6 volts DC and then subtract 65 volts DC to calculate a battery internal voltage of 10.6 volts DC. So the next step is to then calculate the battery internal voltage, the battery internal resistance, but we cannot calculate the battery internal resistance without first calculating the battery internal voltage. So typically one might be looking for the quick shortcut to calculate battery internal resistance and repeatedly getting the value incorrect or repeatedly getting the wrong answer or the wrong value. Let's say you put equipment, an internal resistance meter, and then you get some other value. Or you're studying for your exams and you have to calculate the battery internal resistance longhand. So the trick to answering this question correctly is to first calculate the battery internal voltage, because we cannot know the battery internal resistance without knowing first the battery internal voltage. So we have to use Ohm's law to multiply the load resistance of 2 ohms times the current going to the motor to then calculate the actual voltage drop from the battery into the motor, which is 65 volts. And then we could subtract 65 volts from 75.6 volts, so we calculate a battery internal voltage of 10.6 volts. So now we're able to calculate the battery internal resistance, and that is the Ohm's law formula rearranged to solve for resistance. So E voltage divided by I current in DC circuit. So this is 10.6 volts battery internal voltage divided into the constant current of 32.5 amps, because the cells are connected in series, and series circuits maintain constant current. So we calculate a battery internal resistance of 0.326 ohms. So if a battery internal resistance device was connected to this particular battery, it would read 0.326 ohms of battery internal resistance. Thank you for watching this video, and have a great day.